All right. Got a number of things to go over today. I want to talk about homework 2. I want to talk about um, ODP 406. I want to talk about bash scripting in general and requirements for bash scripting. And then I want to talk about the service learning project. And then I want to talk about programming assignment 1. And today and tomorrow we're going to talk a lot about PA1 and go over algorithms and ideas for breaking your code into pieces and things like that. Hopefully people made a start on PA1 over the weekend, and whatever issues you may have run into, hopefully we can add some understanding to that going forward. If you haven't started PA1 yet, unfortunately you don't get the benefit of trying to work it out yourself and then seeing some ideas. But hopefully everybody's already started on this. So let me begin with homework 2. So as I posted in an announcement, I graded homework 2 and posted grades on Canvas. About 15-20% of submissions did not complete all the required steps. And homework 2, unlike the other homeworks, is really vital to being able to do any of the other work in this course, right? Because this is how you're going to submit all of your assignments that get graded by me. You're going to do it through Git. And so if you can't, create the repository, make a subdirectory, put something in that subdirectory, push it all to Git and add me as a reporter, then there's no way I can grade your other assignments. And so, right, you don't want to get zeros on every programming assignment. So you got to do homework 2, right, even though it was due on Friday. If you got a 0 on it, what I'm going to ask you to do is take another careful look over the assignment and figure out what you did or didn't do that's different from the assignment, correct that, and then send me an email and say, hey, I found the problem, can you regrade homework 2? And I'll go back and regrade it, and we will do that until you get full credit on homework 2, right? Because this one's got to be done. So I mentioned some things in the announcement that I've seen going on with students, versions of this, but make sure that you've got a Git repository named CSE224, uppercase CSE224, no spaces, nothing else in there. Make sure it's on GitLab, not GitHub. Put it under Git control on your Unix machine and then push it over to GitLab, and then add Nick Macias, 10 letters, all lowercase, as a reporter on that project. Okay, that's part of homework 2. Now continue with this homework assignment. So underneath the CSE224 directory that you made up here, make a subdirectory called HW002. Got to be exactly right? Can't be CSE space 224. It can't be, homework 002. Got to be exactly this, right? And then put a README file in there, and then add that to Git. So git add, git commit, git push. And then you're still not done, right? Then you got to go onto the server and send me an email and tell me what your GitLab username is. And that's got to be done by sending me a message with a subject line, uppercase GIT : space, and then your GitLab ID, and nothing else. Now we're up to 62 people in these classes, so it's not feasible for me to go on to GitLab and look at every repository I've been added to and find the name of it and find the user ID and then come and download it and so on and so forth, right? So I'm putting the burden on you to match all of this precisely, and then I can download your projects from there. And once you have this working, right, you start PA1, just make a subdirectory instead of HW002, make a subdirectory PA1, git add, git commit, git push. Right? And the more often you do this and the more ingrained it is, the better the situation, because you have backup copies, and if something happens and you got most of your code done Thursday and then the power went out and you couldn't finish working it, I can still get to the last thing that you pushed over, right? If your hard drive goes to lunch, you can go back to GitLab and you can pull down the last commit that you made. So this just, you know, works more and more in your favor. All right. If you go through this again and you look at exactly what you did and you're pretty sure that you did exactly the right thing and you still can't find the problem, you know, it could be that I messed up. It could be that, you know, when I was putting in grades, I got off by a row somehow or something like that. Come by office hours, right? And we'll double check it. All right. Let's see. Let's talk about Bash. So we went through this worksheet of how to do things in Bash, how to do while statements and if loops, if statements I mentioned on Friday. The beginning of this mentions that in order to receive credit on assignments where you're doing Bash coding, so this is for tests, this is for things that you're turning in that I'm grading manually, you've gotta do it the way that's described in here, right? There are cases where you can use parentheses in a while statement instead of brackets. There are cases where you can use one bracket instead of two. You'll get 0 points for that, okay? You gotta write your while statements like this: while space, double bracket, space, condition space, double bracket, do statements, done. And your conditions need to be either double equal or exclamation equal for comparing strings, or one of these 6 forms for comparing numbers. If you do an if statement, it's gotta be if space, double bracket, space, condition. Again, there's if statements you can write with parentheses. There's just if statements you can write with single brackets. The problem is, right, sometimes you're trying to write an if statement and it doesn't work, and you just keep changing it, you keep trying different things, and eventually you find one that works for this case. But it may not work for other cases. It may work because of something in particular that you're trying to test for. And if you try to do that in a job interview, right, it's going to look like you don't know how to program in Bash. So I want to make sure that when you leave this course, you at least know absolutely one consistent way to do loops with while statements, to do conditionals with if statements, and to do arithmetic calculations using this $paren. If you want to learn other ways to do this, if you already know other ways to do this, that's fine. But for the sake of assessing, I want you to do your Bash code exactly like this. Now, what you do in your Bash code, that's up to you. That's your choice of algorithm. If you're going to use functions, if you're you know, going to do whatever, that's all up to you. But I'm going to be very picky about doing these kinds of conditionals.
In Bash, are you able to write functions like C code?
You are, and I strongly recommend it because it makes your code easier to work with. Otherwise, Bash just becomes this big, long, you know, monolithic script of pain and doom.
Could you write a function for the computer, like for their selection?
Sure.
Just call on that through the loop?
Yeah, you can do that. Yeah, you can do Bash functions more or less the same way you do functions in C. It's all.
Okay, so do you have to declare it up top just like you would C?
I have not gone through Bash functions yet. I'm going to get to it later on, but I'm not going to go through that right now because that's gonna make more confusion. But it's pretty easy to do, and I don't think the order in which you declare them makes much difference.
Okay.
All right, go ahead, everybody, and send me an attendance note. Let me know that you're here. Canvas name dash uppercase here. And let's move on to ODP 406. All right, so let me bring up a window. The Bash statement PDF on Canvas is up in the top under Resources, and it says Bash How-To Summary of Bash Ifs, Loops, and Arithmetic. So it's up there in that beginning part. All right, so let's look at /temp/readme 406. And in general, I'm not going to put a description in Canvas, and I'm not going to say, look at the README. I'll just open an ODP. If it's ODP 407, look for a /temp/readme 407. All right, so 406 is a bash script, and it's basically going to, when you run the script, wait for the user to type in a number, and then print out that many pipes side by side, followed by the number in parentheses. And hey, guess what? This is part of what you need to do in PA1. Every time that you or the computer makes a move, you want to show the new pile of sticks. So the code you're putting inside ODP 406, you'll probably be able to repurpose to print this pile picture. Now it's not exactly part of PA1 because, you know, in PA1 you're not going to ask the user to enter a number and then print out that many sticks, right? You're going to keep track of how many sticks and print that out. But, you know, this is a nice little piece of PA1 that you can work out the code for in here. And the echo-n statement is definitely your best friend right now. So echo by itself prints out whatever you ask it to echo, but it always prints a new line at the end. It moves down to a new line of output. But if I say echo-n, it says don't print out that new line. And so in this case, echo will print out 3 characters, A, B, C, and then it exits. And so after that C, I get the next prompt from bash. So how do we print out n pipes side by side? Make a little while loop. And just loop through n times, and each time do an echo-n pipe. So we could do something maybe like this. And this is pseudocode. This is not bash. But this will give you an idea of what you want to do. Echo-n, a pipe. And then increment I. So, you know, I equals $paren I plus 1. And do all of this inside your while loop. So what's going to happen, right? So we're gonna read a number from the user, and then start off a loop counter at 0. And if it's smaller than the number of things you're supposed to print out a pipe. But don't print a new line at the end. This is like a printf without a \n. Print a pipe, increment your counter. When you come out of this loop, you will have printed num pipes side by side. And now, do something like this. This will print out parentheses, your number, close paren, and since there's no -n, it'll go down to a new line. All right, so something like that. Turn it into bash code, because you can't do less thans and I equals I plus 1. But turn it into bash code, and that should be good for ODP 406. So the behavior of the ODP is the following. If you run this from the command line, if I type 25, it prints out 25 pipes. But test it, you know, make sure it's not doing 24 or 26. So try a small number like 2. Okay, there's 2 pipes. There's 1 pipe. There's 0 pipes. All right, that's good. You don't have to test it with negative numbers. And then once this is working, go ahead and assess it. Do the G command for grade, 10 out of 10, you're good to go. Okay, don't forget your shebang in the beginning of your scripts. Very first line of your script, !! !bin /bash. Gotta be the first line. Oh, my camera died. No, it didn't. Yeah, there we go. !! /bin /bash. If you put something before that with your name, then this does nothing. It's just a comment. And some people are finding assess is getting unhappy. For example, if you call your script something.sh and you don't have a shebang, that can trip up assess. So you want to make sure that anything that's running your script is using bash, because the syntax of all these statements, some of it is bash specific. So always put this in the very first line. and then anything looking at your code will use bash. All right. So questions on any of that?
Can you use shebang to access something other than bash? Like if you wanted to do something really crazy and risky on Git, like shebang then Git?
Yeah, you got to do it just right, because basically it's going to run whatever you specify here, and it's going to feed the contents of this file to standard in, to the input of that program. But there's cases where that's a really, really excellent thing to do. Maybe a little tricky with Git, but yeah, there are cases where we'll want to do that, and we'll see some of those later in the course. All right, let's talk about your service learning project. So if you look on Canvas, down at the bottom, there's a section called Service Learning Project, SLP. So what's the idea here of a service learning project? It's basically an opportunity to work on something that you're interested in as part of your course that you get a grade for, that extends your learning beyond the regular course material and gives you something you can showcase to the world once you're done with Clark. So the idea is, as a student at Clark, you take classes, you get grades, you move on to other classes, you get grades, eventually you graduate, and you probably transfer to your university. And a lot of times, all you have to show for that is a transcript, right, or a degree. And those say, you took the required courses, you got a high enough grade, and you completed. So a service learning project, this is like a capstone project at a university. This is a chance to sort of go beyond that and work on a large project, something that's going to take you, three quarters of work, basically fall, winter, and spring, and gives you something, fairly heavy at the end that you've accomplished, that you can talk about in interviews, that you can put on resumes, that you can describe when you're applying for a fellowship or scholarship, right? And so the topic of the service learning project is totally up to you, right? I don't give you a topic. You get to pick that yourself, which is good, because you're going to spend, 40 some weeks working on this. You want it to be something that you're interested in. You don't want somebody to give you something and say, work on this for the next, 3 quarters of a year. So we let you pick the SLP topic that you're going to work on. And the first part of the process, after you pick a topic, is submitting a proposal to me saying what you're going to work on. So that's what's due October 8th, this SLP proposal. And before I look at the specifics of the proposal, let's talk a little more about what an SLP should or can be. It can be almost anything. You want to learn how to make video games, you could decide you're going to do a video game for your service learning project. You have a dog that you want to be able to play catch with while you're at school because your dog got used to having you around, so you want to make a web-enabled ball tosser with a camera, right? That could be your service learning project. It can be pretty much anything, but it should be something that you're interested in, something that you're going to be happy working on for the next, 3 quarters of a year. And it should be something that will extend your knowledge, something that's going to stretch you. So if you've been making video games, for 6 years, making another video game, probably not quite what we're looking for an SLP. Unless, you've always done, side scrollers, and now you want to make a fully immersive 3D video game that works with, your VR helmet or something. So you want to stretch yourself. You want to learn something new. And it should be hefty. It should take, 3 quarters to complete, or something close to that. If it's something you can knock off in a weekend, you probably want to add to that and make it more ambitious.
Can I ask a question regarding
Sure thing.
First topic. Um, would maybe having something that interfaces with an Alexa device, would that be something maybe it'd be kind of cool?
Yeah, if you wanna dig into Alexa API and get into some web services, there's a lot of stuff you could do in there, and that would be really cool.
I mean, like using hardware and programming it to run through an Alexa command, kind of, is that something that would be
Yeah, that sounds promising.
okay?
Um, so this is something that is more tangible rather than research based.
Well, we'd like there to be some sort of tangible outcome at the end, um, but it could involve a fair amount of research. But yeah, your goal is to, well, if you have something specific in mind, let's talk about it. Because I don't want to say outright that there's no way that a pure research project would work. Um, but yeah, let's talk about it if you got an idea. Usually, it's something tangible. And if you go to the engrcs.com website and click on ECS Club, that's the club that normally meets Fridays when we're in person. Come down to the bottom. There's a sample of past student projects. You can find some videos that students have uploaded where they presented their service learning project. I think these were all done in spring after their final quarter was finished. And this will give you an idea of some things that people have done. So chess game implementation, Wi-Fi controlled robots, mini camera headband, right? Things like that. Dodgeball sounds fun. Tesla coils are always good. So if you're in the STEM building, there's a hallway next to the Nerd Cave, and it's got posters from past students' service learning projects, and you can get some ideas there also.
Yeah, I've seen a couple of those SLPs at the ECS Club. They're pretty impressive.
Yeah, we've been doing presentations online while we're locked down, and people from other classes have been coming just to see what people are doing, and yeah, there's definitely some cool stuff. So what's due on October 8th is your proposal, okay? And two details up front. One, your proposals need to be typed and carefully prepared, and two, a one-page submission will probably not get you a really good grade. Okay, now this template is one page, but avoid the temptation to forget about this until it's due and then print this out and scribble a few things in here and turn that in, okay? That's not what we're looking for. So here's the mindset I want you to be in. You've got a really good idea, right? And there's a venture capitalist who has $50 million to give away to someone who has a really good idea, okay? And you want that $50 million, right? This is the thing that you're going to hand them to hopefully convince them to give you a bunch of money to work on your project, right? So you want to put enough information in here that you could convince a venture capitalist to fund your effort, right? So detailed project description, probably some sort of video game, okay? Well, that may be true. That's not detailed enough to convince somebody to say, my gosh, I want to be the person who funds this project because this is going to be, groundbreaking, right? Now, your project does not have to be, something that's never been done before. It does not have to be something that's going to be groundbreaking. It does not have to be something that somebody would actually give you $50 million for. Because, this is partway through your education career. And the goal is not, to reshape the world or make a ton of money, but if that happens, that's fine. But the goal is to learn and have some fun and get into some new stuff. But when you're writing the description of it, the proposal, try to use this metric of would this completely tell somebody what it is I'm planning to do? Okay, so your name, class CSE224, the date, name of the project, give it a name. It doesn't matter what it is. You can work with up to 2 partners, so groups of 3 people, if it makes sense, right? But if you're going to work with 2 other people, make sure that you have an idea how you're going to split the project into 3 pieces.
One more question about that.
Yeah.
Do those have to be direct peers, or can they be like, I have a friend who's in the first year of the computer science program,
So ideally, you're going to work with somebody who's also taking CSE224. Does not have to be in the same section though. It could be someone from the other class. But if you want to collaborate with somebody who's not taking 224 right now, my suggestion would be try to, even if you're going to collaborate, try to carve off some piece that you can work on and present as your contribution that doesn't need the other person to present in order to make a presentation. Does that make sense?
Yes.
Okay. All right. Detailed project description, right? I want enough information in here that I know exactly what it is that you're thinking about doing. And if it's a project you've been working on, you may have a really good idea what it is, but I don't, right? So put enough information in here that it's going to be clear to me from reading this what you're planning to do. So if you're going to make a video game, right? I'm thinking about making a video game, possibly in Unity, possibly in Unreal. I'd like to do, a first-person shooter that I can move around with my mouse, and I can have some power-ups, and at least 3 levels with a boss at the end of each level. I'd kind of like it to be in the style of such and such, but I want to have some of the features of this other game in there, right? That's a nice detailed description, right? That's a lot better than I'm going to make a video game or some sort of game, right? So as much detail as you can think of to describe what it is you want to do. Now you haven't done it yet, so I don't expect a solution in there, right? But I want to know that you're thought about this and see that detail there. Most challenging elements and expected learning outcomes. The goal is to push yourself to learn something new. So if you've already made a bunch of video games and this is just going to be another game, where's the challenge? Where's the learning outcome, right? So we want this to be more than just another box you got to check to get through CSE 224. So what do you hope to learn out of it? Description of service component. This is pretty easy, right? So just about anything has a service component. So a video game helps people relax. A remote controlled dog ball tosser, helps my dog be happy and lets people go back to work or school away from home without feeling bad because their dog is bored all day. So just think about kind of like, how does this help people? And you can usually find a way to do that. If it's a project you've already started, I'm okay with that. If you've got something you've been working on, this is a chance maybe to take that and actually get credit for working on it more. But just tell me, what the past progress is, what your current status is, and so on. If this is a new project, just say new project. All right, milestones. So, you're walking through the woods and you're following a path, and every now and then you see a marker on the ground with a number on it, maybe, right? That's a milestone. Tells you you've gone another mile. These are very clearly marked indicators of how far you are down a path. And if you know the path is 5 miles long and you just passed the mile marker 3, you're a little more than halfway to the end of the path. Exactly the same idea with milestones on a project. So these are ways to track your progress from where you are to where you're trying to get to. So where are you going to get to by the end of the quarter? Usually in the first quarter, what you're doing with the service learning project is really pinning down the details of what you want to do. You may not actually make a lot of progress towards the final product, but you're narrowing your focus. You're doing feasibility tests. You're answering the unknowns, and when you come out from fall quarter, you've probably got a pretty good idea, okay, here's exactly what I'm doing. Here's how I'm going to do it. Here's what it's going to involve, that kind of stuff. So it's kind of the exploratory phase. So you want some very clear milestones, at least 3 of them. One for halfway through this quarter, one for the end of the quarter, and one for the future. And I'd like you to put down the date that you want to meet that milestone by. So this should be around, week 5, week 6. This should be around the end of the quarter, and this can just be, something you imagine in the future. So beginning of winter term or end of winter term or whatever. And your measure of success. So these are hard to write, right? Your measure of success has to be something that is measurable. Just like, that stone in the ground with a 3 written on it, I can look at that. I know absolutely where I am. I'm 3/5 the way to the end of my 5 mile path. Okay? That's the kind of clarity you want in your measures of success. So let's say you're working on a video game. What's a weak measure of success? I'll have a first version of the game done. Right? Well, what does that mean? What is a first version, and what does it mean when you say done? All right? Here's a more precise measure of success. Um, by week 5, by the end of week 5 of the term, I will have gone through 2 tutorials on Unreal and 2 tutorials on Unity. I will have selected which one I want to use, and I will have built a sample game from a tutorial that does, some sort of user interaction. Okay? And that's pretty clear. You can say, I did that or I didn't do that. There's no, well, I kind of watched 2 videos, but I didn't really, right? You did or you didn't. Did you go through 2 tutorials or not? And you can say, I went through 1 tutorial, but then I decided that, I hated Unreal and I wanted to do Unity instead. Okay, that's fine. But it's got to be measurable, right? And then maybe by the end of the quarter, what should you like? What should you like to have done? I will have a environment in which the user can move around with the keyboard and fire a gun using a space bar, and I will have some sort of enemy pop up that they can shoot. Right? That's pretty easy to demonstrate whether you achieve that or not. And then maybe by the beginning of winter term, I want to have the enemies try to evade my shots. So I want them to move around in response to where I fire my gun. Something like that. Does that make sense?
Yep.
All right. So tell me about the major challenges you anticipate and how you plan to address them. I don't know anything about video game development, and so I'm going to have to do some tutorials, but I found a YouTube video channel that looks really good, and the first 3 videos will take an hour each to go through, and after that I should be able to create a simple side scroller. And so I'm going to do that, and I've also got a book on C++, and so I'm going to start going through that and trying to buff up my my programming skills. Why did you choose this project? What specific interests relate to this project? What do you hope to learn from it? What do you think it will have as far as benefit to your education? So just kind of tell me your thinking about this project. This is as much for you as it is for me, right? I mean, in the end, it doesn't really matter to me, why you're interested in making this particular video game, but think about this yourself, right? And in trying to describe this in a report, you can start thinking more deeply about it sometimes, or thinking about it differently. Plus, I actually am interested. I'm always curious when students are working on a project. What's their background? Why are they doing this? And so on and so forth. So those are the things that I want to see at a minimum in your proposal, right? You can definitely add more. And again, don't just write a sentence here, write a sentence here. Build this out enough to do justice to your proposed project. All right. So that's the proposal, which is due on the 8th. And then there's 2 other pieces to this. So there's a final upload November 23rd. That's towards the end of the course. And this is just a PowerPoint that you will download, fill in, and then upload to Canvas. And you just fill in your title, date, team, problem definition, some of these areas, research analysis, what you did when you explored this, detailed solution that you're proposing, potential applications, and so on. Now, when we're in person, typically after students upload this, we send them to the printer. They get printed on these nice 17 by 11 sheets of cardboard, and then we have an in-person presentation, and students, display their posters, and people come in from outside and walk around, read people's posters, ask you questions, and so on and so forth. We're still going to be remote at the end of this quarter, so the presentation will be done through Zoom. But you can still upload your posters to get credit for that. But then in winter, hopefully, you actually get a poster from it. So the presentation is tentatively scheduled for November 30th. That's the last Tuesday of the quarter. But as we get closer to that, I'll give you more information. And it's usually done just during class time. All right, any questions on SLP?
If you currently have no idea what you want to do, any recommendations? How to find those things?
It's helpful to start with what you're interested in. So if you have hobbies or interests or things that you're curious about, if you can turn that into a project, that would be good, because then it'll be more interesting for you to work on. If you're not interested in anything technology related or curious about anything, then it's a little harder. Or if you just kind of try to take note as you go through your day of things that are missing from your world. Things that you wish, were there, like it's raining and I've got to go outside to see if the mail came. Well, it would be kind of cool if like there was a camera and I could just check and see if the mail came yet, or stuff like that. But yeah, if you can start from interest, that's usually a pretty good way to find a nice direction. So stuff that you enjoy doing. If you like music, there's a million projects you could do in music. If you like watching movies, there's a ton of projects you could do, around that. And like I say, this does not have to be something that has never been done before. In most cases, it won't be something novel, something that's never been done before, but something that's new to you, right? But occasionally, people come up with an original idea, and you can do this in a proprietary way, right? You can your final report that you'll upload in spring, you can put license terms on that, and you can say, this is proprietary, you're not allowed to release this information to anybody. You can use it for grading only. And maybe you invent Netflix socks that detect when you fall asleep and pause Netflix for you, right? Those exist, unfortunately. But something like that. Does not necessarily need to be programming centered. It could be networking based. It could be electrical engineering based. It could be something that has nothing to do with any of that. Tips on setting scope. So it's nice to set the bar high to begin with, because it's rare to go higher than what the bar is set at. And so if you undersell yourself, you'll probably end up underselling yourself for the whole project. So it's nice to set it high, but you don't want to set it so high that you get discouraged, right? If you set it really high and you have to scale it way back, that's totally okay. That's what we're doing in fall, is figuring out what the sweet spot is. But you don't want to get yourself discouraged and think, I'm going to build a rocket ship and go to Mars and colonize it using a 3D printer, and then, find out that, like, you don't have the resources to do that. But you've got a 3D printer and you can make, a pair of boots or something. So that would be cool. How much of a video game can you reasonably create in 3/4 of a year if you've never done video game development? You can get really far. Unity, Unreal, they do so much of the work for you. You can go into Unreal and go through the first tutorial, and you have a video game where you're moving around in 3D, and you can jump up and stuff like that, interact with objects and so on. It's pretty powerful. So yeah, even if you have no experience in video games, you can get pretty far very quickly. Ideally, you work on this throughout each term. In reality, a lot of people turn in their proposal and then do nothing until the night before the final upload is due. And then they're like, oh, I forgot about the service learning project. So they spend a few hours doing some research, they write their upload, and then they spend a few more hours the next week, and then they come into the presentation. That's not a really fun way to do this. It's not a big part of your grade numerically, but you know there's continuity from one course to the other. This carries over for 3 courses, and it's something you can build on after you're done with your courses at Clark. So it's worth taking some time to try to find a project that you can sink your teeth into. And projects are where you learn stuff, right? When I was an undergrad, everything I learned that was useful to me, almost everything I learned came from working on projects, right? I got a little bits and pieces from classrooms, from my teachers and so on, but the real hardcore learning was the projects. And my friends and I mean, we would just hang out day and night in a lab area and work on stuff, you know. And when we finished something, we'd show it to each other. Somebody would say, "Hey, that's pretty cool, you know. Let me try it," and they'd break it, you know. And then you'd figure out like how did they break it, and you'd try to make it better, right? And then you'd see what they're doing, and you'd break their code, you know. And then you'd show them your fix, and they'd be like, "Oh, that's really cool," you know. I mean, this is where learning takes place. Um, So yeah, this is also really great when you're looking at jobs, right? If you're in an interview and they want to know, you know, tell me something about yourself, right? If you can talk about a project that you did, that you managed, that you defined, that you set scopes for, that you set milestones for, that you tracked, that you know, worked on and adjusted and, you know, perhaps even completed, right? That's really valuable to an employer because employers aren't looking for people who can do homeworks and take tests, right? That's not what you're going to do in a job usually. What they want you to do in a job is work on projects. They want you to be able to track your progress and follow through and you know manage milestones and things like that. So this is really good for down the road bragging points. All right, let's talk about PA1. So PA1 is a full-on program. It's going to do a number of things, and it can be a little daunting maybe to try to figure out how am I going to do this. Right? You've got the assignment, you know what it's supposed to do. You've seen a version of it running. How do you start? How do you put the pieces together? How do you make these things happen? This is what we're doing in CSE224. We're trying to get better at this whole idea of taking a problem, this is what I want to do, and coming up with an algorithm, a series of steps for doing this, and then converting that into something that a computer understands, and then having a computer solve this problem for us. So a lot of this is not about programming, it's about algorithms. It's about figuring out what steps you want the computer to do in order to accomplish your goal. So let's look at a high-level view of our stick game. And I'm going to write pseudocode, right? This is like, you know, what I wrote for your ODP. So this may look like a programming language. Some of it may be programming language. Some of it may not. But my goal in writing pseudocode is for me to understand what the algorithm is. When we convert this to code, we're trying to make the computer understand what the algorithm is. But before I ever talk to the computer, I want to know what the algorithm is. I want to figure that out for myself. So how do we play the stick game? We're going to say hello. We're going to get the number of sticks. And I'm just going to call that num. We're going to see who goes first. And I'm just going to think of that as a variable called turn. If turn is user, then the user goes first. If turn is CPU, the CPU goes first. Or U and C or something like that, right? So there's some setup stuff in here. And then we're going to have kind of a main gameplay, right? So if the user turn, if it's the user's turn, get number to take, and I'm going to assume that's a variable called take, and then I'm going to set num equal to num minus take. So I'm going to subtract that number from the pile, and I'm going to print the pile of sticks, and I'm probably going to print the number of sticks up here also. And then I'm going to see if the game's over. So I'll see if number is 0, or maybe if it's 0 or negative. And if it is, I'll congratulate the user for winning, and I'll exit my script. That's the whole user turn. Find out how many sticks they want to take, subtract it from the pile, print the new pile of sticks, and then see if the game's over. And then, if it's the CPU's turn, calculate the number to take, and the rest of it's the same. Take that number off the pile, print the sticks, see if the game is over. And then I'm just going to go back and do this all again. Alright, this is a high-level view of the game. It's missing a lot of detail. But to figure out the flow of the program, I don't care about the details yet. Yeah, I have office hours Tuesday through Friday. And every other Monday, just not this Monday. But after this, every Monday, and this week, Tuesday through Friday. Alright, so say hello, that's an echo statement. Get number of sticks. Well, we got to do some stuff there, because remember, they have to put in a legal number. So we're going to need some kind of logic here, but I'm not worried about that when I'm trying to see what the high-level view is. So this is called top-down design, right? And this is just an echo statement. But this is going to need some logic, so I can, read a number from the user and see if it's at least 15. And if it's not, I'm going to ask them again, and I'm going to keep asking them. So there's going to be some kind of loop, some conditionals, and so on. But that code that we wrote on Friday that I posted on Canvas, try it and try it too. Well, those are examples of this. Try it too was a loop that kept repeating a request for input from the user until the user typed the word BYE. Well, we could use the same idea, the same basic logic structure, to keep asking the user how many sticks until they type in a number that's at least 15. Or, that keeps asking them who should go first until they say either U or C. Alright, and then printing the pile of sticks, well, we're going to know how to do that from doing ODP 406. Alright, is it the user turn? Well, I'll initialize some turn variable based on the user's response as to who should go first, and I'll just do an if statement if, quote $turn, quote equals, quote user, or quote you or something. Alright, how do we get the number of sticks to take? Well, we do a read, but remember, we've got to make sure that they put in a legal number, 1, 2, or 3. So we'll have some other logic here. This is just an assignment statement. Num equals $paren. This is our call to our print sticks function, or our code that prints the number of sticks. How do we know if the game's over? See if num is less than or equal to 0. So that's one thing, is working out the high-level flow first, and then start digging down and filling in some of the details. The other thing you can do is you can change the problem while you're working on this. For example, you might say, okay, I'm just going to always play the game with 20 sticks and the user's going to go first. And I'm not going to worry about this, I'm not going to worry about that. I'm going to do those later, right? Make yourself a simpler version of PA1. Games always play with 20 sticks, user always goes first. And now you can concentrate on this business. I'm not going to worry about illegal entries from the user. I'm just going to let them put in how many they want to take, subtract it from the number, print it out. I'm not going to worry about printing sticks. I'll just print out the value of num. I'll do the pipes later, right? You can pare this down to something much more doable. right? So don't be afraid to modulate the problem while you're developing it. All right, we're out of time. Send me an attendance ping, please. Let me know that you are here. Canvas name dash uppercase here, and I will leave it at that. I will see you in 2:15, or I'll see you tomorrow.